All right. So last bit of problems to talk over. We had 98 problems. I did them in sections, so you guys have them on YouTube to look back at. Your review day is next Tuesday, correct? So come in Tuesday if you have questions. Hey, can you go over this one specifically? That sort of a thing. But remember, I told you guys this last week, but I'll remind you again. I'm going to remind you again when you come in for the review day. You have 50 multiple choice questions, all right? All multiple choice. You are allowed to use your calculator, so calc aloud. And you also will have the formula sheet with everything on it. So just come in here, guys, do the best you can. Let the chips fall where they will. So if we look at problems 82 and 83, what do you notice it says at the beginning of the question? Use what? Law of sines. All right, you're going to have questions that say use the law of sines or use the law of cosines. You will have, I put the law of cosines here so you can see it. Law of sines is just a proportion, sine A over side A, that sort of a thing. But if they tell you what, they're going to tell you what to use. So use the formulas that they're given. Two of the things that I want to bring to your attention is A, pay attention to what they're asking. Pay attention to what they're telling you to use. Pay attention to what they say in the directions. But what do you guys not see in 82 and 83? There's no what? It says use the law of sines to solve the triangle. Do you see the triangle? No. What should you do? Draw it. Give yourself a visual of what you're working with. That makes your life easier. Here's A, B, and C. It doesn't matter where you put A, B, and C. Just make sure with or whatever letters they give you. But whatever they give you, make sure you're matching the information that they give you and put it in the right spot. So they tell you side A is 27. Well, that's across from angle A, so this is 27. Side C is 29. That's across from angle C. And they tell you that angle A, whoops, too big. Angle A is what? What's angle A? How much is angle A? 27. They tell you angle A is how many degrees? 52 degrees. Now that you have that information, you can see, oh, I see the side length and its corresponding angle measure. They are giving you the values to use. Sine 52 over 27. And then now you solve to find another angle. What angle do you have to find given the information? Got to find C. Do you know anything about side B or angle B? No. So you have to say, okay, well, I'm going to find the sine of C, and I know that the side. So we're going to cross multiply. We're going to do all this, but we're going to come out where something says sine C equals. I'm going to get some random decimal, correct? Is that going to give me the angle measure? No. It's going to be the sine of that angle. So that's where you have to go, sine -1. Second sine, and then you put in whatever that decimal is, and it'll tell you, here's the angle. What happens if it says error? What does that mean about the triangle?
It's like not real.
It's not real. There isn't one. No triangle. So don't second guess yourself and say, oh, no. Now, I would second guess myself if there's 4 answer choices and none of them say no triangle. Then you definitely did something wrong in the calculator. But it's okay. If one of the answer choices is no triangle, that might be a plausible option. So just go with it. Same thing here, guys. It says law of sines, so that means use the law of sines. If it were to say law of cosines, that means they're going to give you 3 sides. So you would use one of these.
And on the
A formula sheet?
it's gonna like say
Yep. I just absolutely copied and pasted that. So it'll tell you, and it has both of them. It has the alternate form and the regular form. All right, so like this one, what is this telling you to use? Heron's formula. Some of you guys are like, I don't remember Heron's formula. I copied and pasted this from the formula sheet.
and it says like parents will
That is exactly what it looks like. Like I literally just circled it. So it says Heron's formula. So first thing you need to do is find S. Well, how do we find S? What does it say to do? You add up all 3 of these. So we're going to say 45.7 plus 31.6 plus 29.5 and divide it by what? 2. What is the important thing to pay attention to right now? If you're going to do this in your calculator, if you do it all in one step, what does the numerator have to be in? You have to tell your calculator, hey calculator, add the whole top, then divide by 2. If you'd rather add those 3, hit enter, then hit divide by 2, fine. But if you don't put that in parentheses, what the calculator will do is divide 29.5 divided by 2, then add it to those other things. That is a major, major, major thing to pay attention to. So once you get that value, guys, then what do? You put it right there, and then you just subtract that number minus the A side, that number minus the B side, that number minus the C side. Multiply all that together and take the square root. This is just it tells you what formula to use. You guys have to use your calculators properly. That is a question you should not get wrong. Everybody understand that? These questions up here, you don't necessarily have to work out the entire problem because this is multiple choice. So find right here, we would have found angle C. So look at the answer choices. Find your correct angle C. Mark out the ones that aren't the right one. Use your test taking skills so you guys aren't wasting time. Does that make sense? All right, let's look. Okay, this I took from the formula sheet. You guys are going to have all the fundamental trig identities. This generally is the hardest part of the final. For pre-cal it was as well. Because A, this is kind of a long time ago that we did this. And B, this wasn't anything that you guys were super familiar with. So we learned it or we memorized it as much as we could, then we got it out of our brain. All right, so if you struggle with these, okay, fine. I told you guys last week, if you struggle with something, focus on the stuff you know how to do really well. And then, do the best you can on here. But again, it's multiple choice. So if we are simplifying, let's remind ourselves some things about simplifying. What are the 2 most basic trig functions? Sine and cosine. So when all else fails, try to just go to sine and cosine. Think algebraically. I told you guys that. You want to think algebraically. And again, you should be able to eliminate answer choices because it's multiple choice. So if I look at this first one right here, if I'm thinking algebraically, that means can I factor something out, something like that. Do you see anything in common between the first term here and the second term here? What do they both have? They both have a cotangent. They both have a cotangent of theta. So I can factor that out. It doesn't go anywhere. I just bring it out in front. And then I'm left with secant theta minus what? Cosine of theta. All right, so let's just think for a second. Before you guys are like, oh my God, I can't do this. Is there a relationship between secant and cosine?
Yeah.
They're reciprocals of each other, right? All right, so I don't know what else to do right now. I can't just subtract these. So let's just go to our 2 most basic trig functions, which are what and what? Sine and cosine. So what is cotangent the same as in terms of sine and cosine?
1 over tangent.
Or in terms of sine and cosine? Cosine over sine, right? Okay, so I'm going to rewrite this as cosine theta over sine theta. And then secant is the same as 1 over cosine theta minus cosine over what? 1, all right. Now, can I just cross out that cosine with that one?
No.
Why not? You're correct, but why not?
Because one's in the parentheses. So
This one has a minus sign, right? If it was all multiplication, you could. So we just have to leave that outside for a second. So I have 2 fractions that I'm subtracting. When you guys subtract fractions, you have to have a common what?
denominator.
Okay. So what would a common denominator be between cosine and 1? Cosine. So if I multiply the bottom here by cosine, I have to do it to the top. When you multiply cosine times cosine, what does that equal? Cosine squared. Okay, so what we just did here, I'm just going to come over here so I have a little more room. I still have cosine over sine on the outside. And then on the inside here, I have 1 minus cosine squared theta over cosine theta. Now, can I get rid of the cosine on top here and the cosine on the bottom here? I absolutely can, because we're not adding and subtracting anymore. If you guys aren't comfortable doing that yet, that's okay. Let's look here. We talked about Pythagorean identities. If something has a cosine squared and it's attached to a plus or minus 1, can I rewrite 1 minus cosine squared as something else? What's 1 minus cosine squared the same as? Okay, so I'm going to cross this out, and I'm going to make this a sine squared. Now 100%, guys, can I just cross out top and bottom stuff places? Yes. So I can say, okay, this cosine and this cosine cancel. This sine cancels, and there's only one left over. So what we did was we simplified this whole thing to just be what? Sine of theta. Now I know some of you are like, oh my God, what? Okay, do the best you can. Use your trig functions, use your identities, and simplify as much as possible. Think algebraically, and what are the two most basic trig functions? Sine and cosine. If we think that way, we'll be all right. Think about this. Is there anything being added, subtracted? No. Anything squared that's attached to a plus or minus 1? No. So let's just go to sines and cosines. So this is sine of theta over 1. Good. And what is secant the same as? What's secant the same as? 1 over cosine. Okay, so 1 over cosine. So if I'm going to multiply this, this gives me sine over cosine, which is what? Yep, perfect. Very good. All right, this one looks a little more difficult because now we have stuff squared, but wait a second. When something is squared or attached to a plus or minus 1, we look at our Pythagorean identity. So 1 minus sine squared, what's another way I could say 1 minus sine squared? Cosine squared. So I'm going to say this is cosecant squared times what? Cosine squared. All right, what are our two most basic trig functions? Sine and cosine. So cosecant squared. What's cosecant the same as? 1 over sine. So I'm going to change this to 1 over sine squared. And this is cosine over 1. If I multiply these two together, I get cosine squared over sine squared. What's cosine over sine the same as? Sine over cosine is tangent, so cosine over sine is cotangent. But again, guys, you're going to have these right here in front of you. I know this. I have it memorized. But look, cosine over sine. Cosine to the fourth over sine to the fourth is just cotangent to the fourth. All right, again, I know those are probably, you guys are like, oh, I hated those problems. Okay, just do the best you can. All right, this one's a little trickier. This says cosine squared theta minus 1. Is there anything over here that says cosine squared theta minus 1? It says 1 minus cosine squared, right?
Yeah.
So that's a little different.
Can you just like move them?
How could you just move it? It would be negative 1 plus cosine. What would I have to do to get the signs to change?
You add 1.
Not add it. What would I have to multiply the top by to get the signs to change? How do you make a positive become a negative? Multiply by what? Negative 1. So if I do that, I have a negative outside here. This becomes negative cosine squared plus 1, right? Over cosecant. Well, I could rewrite that as 1 minus cosine squared, couldn't I? Well, now, what do we know 1 minus cosine is? Squared. What's 1 minus cosine squared?
Sine.
Yep, sine squared. So I have negative sine squared over cosecant. Well, what is cosecant the same as?
1 over sine.
Okay, so this is negative sine squared theta over 1 over sine. Do I have two fractions?
Yeah, keep changing.
We keep change flip. So negative sine squared times sine over 1. What does that become?
Negative sine. So yeah.
Perfect. That was a hard one. Totally understand. That was a hard one. All right, now let's talk about solving. You guys are going to solve a regular equation. But this one little extra thing is I have to know what I'm looking for on the unit circle. So let's remind ourselves. If you have the x value, or let's do it this way. Let me write it like this. Your x comma y, right? What is your sign? What part of the ordered pair is your sign? The x or the y?
Sine is y.
Sine is y. Good. What part of the ordered pair is the cosine? And what part of the ordered pair is tangent? Y over x, right? So your reciprocals, reciprocal of sine is cosecant. That's 1 over y. It's just flipped. Secant, you flip. It's 1 over x. And cotangent, good, is x over y. If you guys can remember that, then these are super easy to do. Because think about it. You're solving. You want to get this tangent x by itself. So what do you do to both sides? Divide by square root of 3. Okay. So I have tangent of x equals 1 over square root of 3. So what this is saying is where on the unit circle would you get the tangent to be 1 over the square root of 3? If you don't like looking at it like this, you could write it as what? Square root of 3 over 3? So what that's saying is you want a positive square root of 3 over 3. That means you take the y value, you put it over the x, and you get positive square root of 3 over 3. So think about what two quadrants could that be in? First or?
What was the number?
It's a positive. And the third. How come the third?
Because the
What's a negative divided by a negative?
positive.
A positive. So you're looking for which ordered pair, guys, is going to give you the square root of 3 over 3. Well, there's only two options. It's either going to be this one or this one. If I do this one, what happens when you put the same number over itself? You get 1, and it's not going to be one of the quadrant angles. So you need to figure out, if I take right here, if I take the square root of 3 over 2 over 1/2. If you keep change flip, you have square root of 3 over 2 times 2 over 1. What is this going to give you? Square root of 3. What are we looking for? Square root of 3 over.
Yeah, over 3.
So it's not this one. It's going to be pi over 6. And what else? What other one is root 3 over 2 and 1/2? Pi over 6 and 7 pi over 6. So your answer here would be pi over 6 and 7 pi over 6. If it was plus or minus, it would be all four. That the ordered pair is root 3 over 2 and 1/2. So in a case like this, we're trying to get secant by itself. What do I do to both sides? Divide by 4. So I have secant squared x equals 2, right? Well, I don't like looking at secant. That's not one of my trig functions that are, this is a reciprocal function. What is secant the same as?
So 1 over.
But what trig function is it the same as? Secant goes with what? Secant goes with what?
Goes with cosine.
Okay, so I'm going to rewrite this as cosine squared x equals, when I flip 2 over 1, what does it become? 1 over 2. All right, so now let's solve this. If I want cosine, not cosine squared, I have to take the, okay, so you have cosine x equals, when you take the square root, what goes in front? Plus or minus, right? So this is the square root of 1, which is 1, over the square root of 2. We don't like the way that looks. So what is it, how, when I rationalize it, do you guys agree with me? It becomes square root of 2 over 2? So you're looking for what? What is the x value? What is cosine? It's the x values. So you're looking for all four x values on the unit circle that are root 2 over 2. So when I go to my unit circle, root 2 over 2, negative root 2 over 2, negative root 2 over 2, positive root 2 over 2. So it's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. What do you guys notice about the denominators of all of them? They're the same. They should be. They all should be. You should have something together. All right, how's this one a tad bit different? We're almost done. How's this a little different? Looks like a factoring problem. It's exactly what it is. Do you notice how these are both the same? So that's fine. You can just factor this like normal. What's going to go in the front of each parenthesis? Cosecant. that. So I have factors of -2. What's going to give me a -2 when I multiply, but a -1 when I add? -2 plus 1. And since my a term is not 1, I'm going to divide both by this. So I have cosecant x minus 1. And I have cosecant,
Is it 2 cosecant?
yep, 2 cosecant x plus 1, yeah? Okay, set them both equal to 0. So cosecant x equals 1. And here, cosecant x equals -1/2. All right, cosecant. Is cosecant one of our original trig functions? No, it's a reciprocal. What is the reciprocal of cosecant?
Secant?
With
Sine?
sine. Yep. So I'm going to rewrite this as sine x, and when I flip 1 over 1, what does it become? 1. I'm going to rewrite this as sine, and when I flip this, what does it become? -2. So sine is y values. Where on the unit circle is the y value +1?
Pi over 4.
Y value +1.
Yeah.
Just pi over 2, right?
Two.
Okay. Pi over 2. Now, where on the unit circle is the y value -2? Anywhere? No. So is this one on our unit circle? No. You'd have to use a calculator for that. So in that case, that one doesn't exist. You can find the sign of a negative number. It's just not on the unit circle, so you'd have to use a calculator. Okay, we're getting there. This is the same thing. I'm not going to do the whole thing. The only thing that's different is what? They're not the same. So you need to make them the same. You always want to go to the middle, the one that's to the first power. So this will become 2. Instead of sine, I'm going to make it 1 minus cosine. That's just a Pythagorean identity. Plus 3 cosine x minus 3. And then you go about solving it. You distribute. So 2 minus 2 cosine x. Sorry, I'm trying to go too fast. Cosine squared x plus 3 cosine x minus 3 equals 0. We're going to combine here. So you have -2 cosine squared x plus 3 cosine x minus 1. Divide everything by negative. So you have 2 cosine squared x minus 3 cosine x plus 1 equals 0. And then you factor just like we did the last one. Cosine is your x values. So you're looking for, whenever you solve this, the x value in an ordered pair that gives you whatever that comes out to. All right, so these two, all right, both of these, 96 and 97, these are super easy problems. You just have to know what you're doing. It says use the sum and difference. Here's the sum and difference. It's when you add or subtract two angles together. So in this case, they're giving you 285. Guys, 285 is not on the unit circle. But there are different angles that you could add and subtract to give you 285. There's not only one right way. There's a bunch of different ways that you could get 285. I'm going to use 225. Do you guys agree with me that if I add 225 and 60, I get 285?
Yeah.
Okay, both of those are on the unit circle. 225 is -√2 over 2, -√2 over 2. This is my x value, or my cosine, I should say. This is my sine. And 60, what's the ordered pair at 60? Pi √3 over 2 and 1/2. So √3 over 2 and 1/2. This is my cosine, and this is my sine. So we've identified two numbers that add to this. So which formula am I going to use? Well, what are they asking for? Which trig function? Sine. And what did we do to the two angles? Are we adding 225 and 60 or subtracting them? Adding. So this is the formula that I'm going to use. Does everybody understand why I picked that one? So it's sine of one, cosine of the other, plus cosine of one, sine of the other. So I'm just going to say this is my A, this is my B. So it's sine A cosine B plus cosine A sine of B. Well, what is the sine of angle A? What's the sine of the first angle? What's the sine value? -√2 over 2. What's the cosine of B?
Uh,
Root 3 over 2. Good. Plus, what is the cosine of A? Negative root 2 over 2. And what is the sine of B? 1/2. And now we just simplify. If you multiply a square root times a square root, it just makes a bigger square root. So I have negative square root of 6 over 2 times 2 is 4. Plus negative square root of 2 over 4. What do you notice about the denominators? They're the same, so I could rewrite this as negative square root of 6 minus the square root of 2 over 4. You cannot simplify that anymore. You can't say that negative root 6 and negative root 2 are negative root 8. That doesn't work like that. If they were the same, you could combine them, but they're not. 97 is a working backwards one. They're giving you the formula already. You just have to figure out which one they're doing. So which formula goes cosine, cosine, sine, sine? Cosine, cosine, plus sine, sine. Which formula? Cosine of what? A minus B. So you're working with cosine of A minus B. So this is the same as cosine 392 minus 92. Well, what's 392 minus 92? 300?
yeah.
This is the cosine of 300. So it says to write it as one single trig function and then find the exact value. Well, what does that mean, cosine? What value is cosine, x or y? Cosine is your x. So go to the unit circle. Find 300. What is the x value? There's your answer. You're just working backwards. So this would be like this. All right, I'm not going to work through this whole last one. Basically, I worked it all out. But, guys, this is a tough question because it's long. All right, they're telling you right here which of the sum and difference formulas to use. They're telling you to use this one, sine of A plus B, alpha plus beta, whatever. But they're not giving you stuff on the unit circle. They're giving you x, y values, and you have to find x, y, and r for each. All right, you have two triangles that they're talking about, alpha and beta. You can name it whatever you want. But they told you that the cosine of this first one is 15 over 17. What are they telling you if they're giving you cosine? They're giving you x over r. What do you know about r? It's always what? Always positive. So how do you find y in this case? Pythagorean theorem? Okay, so 15 squared plus y squared equals 17 squared. 225 plus y squared equals 289. What's 289 minus 225? 64, good. So y squared equals 64. So y equals what? 8, right? Y equals 8. Now this second piece is really important information. They're telling you that this angle lies between 3 pi over 2 and 2 pi. What angle does this lie in? The fourth quadrant. So what is that telling you about your x's and your y's?
Y is negative.
Correct. Now it's really easy to figure everything out. What is the sine of this angle? Sine of this is negative 8 over 17. What is the cosine? 15 over 17. Why is that important? Because you're going to plug it into the formula. So now you have B, all right, or beta, x, y, and r. They told you tangent, which is y over x, is negative 12 over 5. So, y is 12, 5 is this, but you don't know which one's negative, do you? Could you figure that out? Yep, because this tells you it's between pi over 2 and pi, so it's here. So what's negative if you're in the second quadrant? X is negative, good. So to find r, you have negative 5 squared plus 12 squared equals r squared. 25 plus 144, what's 25 and 144? 169. Square root of 169 is 13. So now here for beta, you can do the sine of beta is 12 over 13. And then your cosine of beta is negative 5 over 13. So now why is that important? You take those fractions and you plug it into this formula. The sine, we've already done this one. Sine is sine of one, cosine of the other, plus cosine. So it goes like this. It's sine alpha cosine beta plus sine beta cosine alpha. Now again, you're going to have those. So now you just plug in. The sine of this is negative 8 over 17. Cosine of beta is negative 5 over 13 plus sine beta 12 over 13. And then cosine is 15 over 17, right? All right, so 2 negatives gives me A. When I multiply 2 negatives gives me A. So 8 and 5 would be 40 over, what's 17 times 13? 221. Plus, what's 12 times 15? 180 over 221. What do you notice about these two denominators? They're the same. They should always work out to be the same. So now I add 180 plus 40, and I get 220 over 221. Look to see if it simplifies. It doesn't. That is a really long problem, but there's really not that much work in it. The hardest math you have to do is the Pythagorean theorem. But you need to understand these. Oh, I don't have them on here. You need to understand that sine is y over r. Cosine is x over r. Tangent is y over x. And then if they give you the reciprocals, they're flipped. Cosecant would be y over, or r over x. Secant, should be y, I'm sorry. Secant would be r over x, and then cotangent would be x over y, right? All right, so guys, when you come in here, tomorrow you can ask questions if you want to, but when you come in here on Tuesday for the review, you need to be asking about anything that you have questions on. Go back over Miss Glick's that I posted. Everything all worked out. Just say, hey, I don't understand how she did this, okay?